So we're going to be doing this thing called factoring by grouping later. And we're going to remind you why we factor, which is basically to find the x-intercepts. So I gave you this problem on the start here, and I said factor that. But here's why you would factor it. Because once it factors to 2 parentheses x plus 5, which I assume you got. Raise your hand if you got that. Okay, awesome. Let's say that problem had been equal to 0, and now it's equal to 0. You'd look at this and go, oh, -5 makes it equal 0. Do you get that -5 then is an x-intercept? And it's also called a 0. Make sure you get that. -5 is both the x-intercept and it's called a 0 because it makes the equation equal 0. Both the original one that I gave you in black and the red one. They both, when you stick -5 in, they make it equal 0. All right, let's go to the simplest of all factoring. 10. Factor it. This is factoring. Just making it into that. It's factoring. Was there another choice? Yeah, what was it? 10 times 1. Okay, good. And it's not like either of those is better. They're both factored form. But that's factoring. All right. All right, let's move up the notch to this like kind of normalish factoring. X squared plus 3x minus 4. And if there's no equals 0, then all you can do is factor it. Now to walk you up from the easy to the hard level, I want to remind you of the steps. Each time you go, did you even think about, was there anything to factor out of all 3? Because you should have thought that. That's the first thing you look for is, do they all have a 2 in them? Because if so, you should have started with that. Now, some of you didn't even think about that, which I understand. But you got to look for that. It's called the GCF. See, like if I gave you another one that started with 2x squared plus 4x minus 2, you'd go, ooh, they're all even. I can factor a 2 out, and that would be critical. But back to this one. Now that I know that there's nothing I can factor out to the front, then I can go x, and then the next thing, I'm telling you, I'm a little different than most teachers on this, and I think it's different better. You need to do the signs here next. Because sometimes you can look at this one and go, no, that can't possibly be right. Because do you get there was a negative in the problem? If there's a negative in the problem, there has to be a negative in the answer. But now the question is there 2 negatives? No, because this comes out negative. Then these 2 numbers here and here, one has to be plus and one has to be minus. Do you now know that I have the signs right? The signs have to be right now. And now you're left with only a really simple thing. What multiplies to 4? And it's either 2 and 2 or 4 and 1. And I think by now most of you know it's 4 and 1. And then you can be strategic. Instead of just randomly slapping in the 4, you can go, I want it to come out with a positive 3. So maybe I should make the positive number the bigger one. There you go. That's the smart way to factor this out. And now to just double check it, I'm going outside and inside, and that's where all the mistakes are made. If you're going to make a mistake, it's because you're outside and you're inside. Don't make this. But in this case, they do. All right. Here's a harder one. Ready? Walking up from easy to hard. And then it'll be to nobody can do it. And then I'll show you how. All right. Ready? Factor that. All right, did you realize there was a 2 in everything? Because see, some kids didn't notice, and they're going to start with a 2x and an x, and they actually could still save themselves at this point if they notice that if you started this way, I'm just going to show you what would have happened. You'd go, oh, there's a negative in the problem, so there has to be a negative. And since this one's negative, it has to be a negative and a positive. And then to make it 10, I'm probably going to use a 5 and a 2. And I'm going to use the 2 here and the 5 here. And then actually, you would think that this would have worked. But then why doesn't it actually work? This is going to happen to tons of you on the test because you're going to have this and you're going to go, but I factored it. Why isn't my answer okay? It multiplies out. Why isn't this okay? Because it's not factored all the way. Do you get there's a 2 right there that could be factored out? There should have been a 2 factored out at the beginning. So if you'd just notice at the end, you could still go, oh, take the 2 out of this. And the 2 comes out, and I have x minus 1, and then I have an x plus 5, and that is the actual right final. Oh, I just wrote that wrong. That's a 5. And that is the right final answer. Raise your hand if you had that final answer. Awesome. The smart way would have been to take the 2 out first and the GCF. But if you don't notice that, at least go through and look at your answer and go, could I factor this further? Oh, yes, I can. All right. Next kind. X squared minus 16. Factor it. Compare your answer with the kid next to you. Mark Y, what did you get?
X plus 4, X minus 4.
Yep. Nice. Okay. That is called difference of squares because that's a difference because it's a minus problem. And that's a perfect square and that's a perfect square. Okay, cool. All right. Next kind. It's kind of like that last kind. Factor it. Fanning, did you notice that there's a 4 in both of those? Excellent. Now, see, some kids started with 2x and 2x, and they could still be saved at the end of the problem if they notice they're not factored all the way. But the smart way is to factor out the GCF right away. And then you just got x squared minus 4, which is like, oh, that's the easy kind. X plus 2 and x minus 2. But if you're the kid who just went, well, I wanted to do it this way, you can do it this way. And a plus and a minus and a 4 and a 4. And then you're going to just complain when I say, no, that's not factored all the way. Do you get that this has a 2 in both parts and it should have been factored? And so that also has a 2 in both parts. That should be factored all the way out. Okay, so then the final answer is actually this. Okay, good. Now the kind that nobody knows. Actually, somebody's going to figure it out, though. Without even teaching you, somebody's going to figure this out. Factor it. Consider this challenge to my kids that are at the top of the class, and everybody can give it a try, and you never know. Some things you can count on. If there are 3 terms like this, then you know there's 2 sets of parentheses. Yes. That's something that just always is true. Okay? Next thing that you can count on. These 2 need to multiply out to x to the 4th. And now just, what's your gut feeling? Do you think it's x to the 3rd and x to the 1, or do you think it's x squared and x squared? X squared. Yeah. This isn't that bad. Like, it's not impossible. You could have figured this out. Raise your hand if you got that far. Awesome. Does anybody think they get the final answer? All right, one person, one bold, maybe two, maybe three. All right. Well then, what did I say to do next? Signs. You should at least be able to do the signs. Is it plus and plus? Well, no, it can't be plus and plus. So just like take one more step. If you're stuck, be just like, okay, I guess so. I guess I can at least do the signs. It has to be a minus because there's a minus in the problem at all. And then if there's this number's negative, it must be a plus. Now I'm down to just one thing. See, if you got that far, you could have asked yourself, well, I guess it has to multiply to 6, right? And if I put a 3 here and a 2 here, that will multiply to -6, won't it? So now I just have to check, and is that actually the final answer? I have something wrong here for sure. In fact, I have multiple things wrong. What could you say is wrong? Like, can't be that way. No way it could be that way. Yes?
You're forgetting the x squared.
Very good. There has to be a squared right there. They both have to be x squareds, okay? What else tells me that this is wrong? Because it is. 3 times 2 does make 6. In fact, there's even a negative. So it's that part's right. Yes?
You gotta switch the signs because
Wait. First, tell me what you get if you don't switch the signs.
it'd be positive x squared.
There's 2x squared for this, and there's minus 3x squared for that, and together those make negative x squared. Don't they? Okay, so then what's wrong with it? Is there anything wrong with it? I just checked it, and I think it just worked, didn't it? Okay, I guess then that's the answer. Anybody figure it out before I said it? All right, there was several people that figured it out without coaching. All right, so a few things I've said that it's rare to be able to say always. If there's 3 terms like this, then you're going to have 2 sets of parentheses. You can still do the signs next. And then you're left with just this number times this number has to make -6. All right. The next, this is not impossible. This is just difficult. 2x squared plus 2x, factor it. Are you going to have 2 sets of parentheses? No. You have 2 sets of parentheses when you have 3 terms. We only have 2 terms. And we shouldn't. What'd you get?
2x multiplied by the quantity of x plus 1.
Very good. All right. Next one. Two x squared minus 9x minus 18. Did you even look to see if there was anything that could be factored out of all of them? If you didn't even look, you lose, because that's going to happen on the test, and sometimes there is, and sometimes there isn't. Well, in this case, there isn't, but you should have looked. All right, next, 2x and x. Did you know how to start? Garrett, what's next for sure? Yes.
Oh, we have to find the signs.
Yes. Do you think it's plus and plus?
No,
What do you think it is?
I think it is a minus and plus.
Yes. This first negative is here because there is a negative in the problem. And the second one, it's whether or not this number's negative. So, yeah, minus and a plus. Finish it off. Mr. Z.
You put, 6 and 3.
6 times 3 does make 18, but 9 and 2 also makes 18. How do you know that that's the right combo?
Because 2 times 6 is 12 minus 3.
That's 12x minus 3x, and that makes 9x. Wait a minute, that makes positive 9x. You are so close. Do you know what to do? Hint, be careful. You have the wrong sign on your answer. Now, I saw you say like switch, but there's 2 things you could switch. Since you have the wrong sign on your answer, switch what? Yes, the signs, not the numbers. If you switch the numbers, it will be wrong. If you switch the signs around, then this will be positive and this will be negative. And whenever you get the opposite of what you wanted, you switch the signs. All right, that's a key moment for some of you, I think, is you can't just switch the numbers around. Sometimes you switch the signs around. And it matters because of this 2 right here. Now you're going to be multiplying the 6 by 2. If I had switched the numbers around, then that would have been multiplying the 3 by the 2, and it totally would change your answer. That makes a total of negative 9x. So yay, I've got the answers. Okay, and now the kind I've been working up to. If anybody knows this, it's only because they figured it out, because I have never taught you how to do this kind. Wait. Can you factor that? I'll show you how in a minute. See, what's weird is that there's 4 terms. Did you even look to see if there was anything that could come out of all of them? Good, that was a good look. There wasn't anything, but you should have looked to see if there was anything that could come out of everything. Sometimes that's the secret. Now, you'll know if you're right because whatever your answer is will multiply out to what you see on the screen. If you can get something to multiply out to that, then you've got possibly the answer. Now, just to clarify, if it multiplies out to that, it's factored, but is it factored all the way? I'd have to see your parentheses, because sometimes kids have like 2x plus 6 in their parentheses, and it multiplies out all the way, Mr. Server. But see, there's a 2 that you should have factored out. See, just make sure yours is factored all the way if you think you've got it. All right, anybody think they've got it? In a class this big, there's usually somebody. One kid may have it. Do you think you have it?
I don't know.
All right, maybe. All right, Ethan's a little more confident. He's actually raising his hand. All right, give me a shot. What do you think?
X plus 4.
X plus 4.
And x squared minus.
X squared minus 3. You are correct. Now, if you're like, how the heck did he do that? I will show you in a moment. Now, how do I know he's right? Well, I actually already factored it, and so I know the answer. But if I wanted to check him, I could go, would you agree that those two multiply to x to the third? Okay. Then Would you agree that 4 times negative 3 makes the negative 12 at the end? Okay. And then I could check this, and look at that. One of them makes the 4x squared, and the other one makes the negative 3x, which are in the problem. All right. So I know he's right because I multiply it out and see that. But literally, only one person. Did you have it a chance? Okay. All right, good. So here's how you do it, though. This is the critical part. This is the actually new learning for today. Some of the best generals in world history that have won the most wars used a strategy called divide and conquer. If they could get a kingdom that they were going against to be divided up, and if they could use their whole army to just attack half of the other guy's army, they'd be able to just kick their butts. So they divide it up and conquer it. We used that strategy in World War II because Germans knew we were coming in to France. They knew we were coming in. They figured we were either coming in here or we were coming in here. And they couldn't defend both spots. We were going to have our huge army, tons, thousands of guys, and they were all going to go onto a beach somewhere. They knew that. And we needed to try to get our whole army to go against just part of the German army. Do you guys know if we went north or south? Don't just guess. Does anybody know? All right, we went south, but we had tricked Hitler into thinking that we were going to go north, and he had his best armies up there. So we went south, and we went against a small, weak army, and we still lost thousands of guys in the first minutes. Thousands of people died on that beach. And can you imagine if we'd have got up against his best army? His most trained guys, the best artillery, the best tanks, all that stuff would have been there. It would have been a bloodbath. So we got his army divided into 2 parts. And we faked him out, and he put his best divisions up there, and we landed here. That was one of the biggest moments of the war. All right, why am I talking about war? Well, because you have to divide and conquer this, and here's how you do it. We break them up really nice for you, so you can just draw a jiggly line right there. And conquer it 1/2 at a time. Can you factor the first part? Just focus on the first part. Just this part. Can you factor that? Yeah, you can. What comes out of both of them? X squared. And what's left? X plus 4. And if you can do that part, then this part's really easy. What goes into both of these? Be careful. -3, very good. And what's left? X plus 4. Do you think that the fact that the X plus 4 and an X plus 4 here is a coincidence? No, that was a big deal, because now this is the part that's going to blow some minds. Some people will not understand this. Look at this whole thing, and in this part and this part, there's a greatest common factor of X plus 4. And if I factor out the X plus 4 to the beginning, what's left? X squared minus 3. That's how you factor that kind. I like giving that example of divide and conquer because that is a truism, something that's held true over the ages. Many, many, many battles have been won that way, where you concentrate on half at a time. Okay, but this actually has a name that's called factor by grouping. I think that's much more boring. I like the name divide and conquer. All right, let's do another one like that. Except this time, you've been taught how to do it, so hopefully you can figure out what the answer is without me having to coach you through it. All right, this one is x to the 3rd minus 3x squared plus 2x minus 6. All right. Did you even look to see if there was anything in everything? Did you even look for a greatest common factor? Because that's going to happen on your test. See, do you get if they had all been even numbers, then 2 could have been factored out at the very beginning and it would make your problem so much easier. All right. In this case, if you looked, all right, you win. If you didn't even look, you're still missing something. Look for something in common. All right, next you do the divide and conquer thing. First two terms, x squared comes out, and you have x minus 3. These two terms, 2 comes out, and I'm going to put a plus 2, and it matters, x minus 3. And then, coincidence? I think not. And those two become the common factor that comes out to the front. They both have this in them, so they're factored out to the front. And then what's left behind is the x squared plus 2. Raise your hand if you had that one right. Awesome. Okay. Now, the King Kamehameha, the big kahuna. You ready? 2x to the third plus 14x minus 2x minus 14. Mr. Friday, did you notice?
I did notice.
What did you notice?
2.
There's a 2. You take that out first and your life is so much easier. And I just screwed up. Stop. I forgot a squared on this 14x right here. That will totally change the problem. I'm so sorry. I just forgot that squared right there. Okay. There should be a squared right here. Otherwise, it won't work. All right. So then that means that it's 7x squared here minus, and the 2 comes off of that 2x, and it's just an x, and then that 14 divided by the 2, negative 7. Problems are so hard, Mr. Server can't even write the problem right. All right. Now I do divide and conquer. Squiggly line. In this part, an x squared comes out, and I have an x plus 7. This part, a negative 1 comes out, and I have an x plus 7. If you did different numbers here and here, you know you're doing something wrong. See, I know some of you thought we just had an x minus 7 over there. You did it wrong. And you could tell because these aren't matching then. All right, so x plus 7 is correct. Now, the big... How many of you are done? Raise your hand if you're done. That's almost everybody. All right, so here's the big reveal. 2 is still in your answer. If you forgot and you just left it behind, don't leave any numbers behind. All right, the 2 is there. And then this part that was in common on both was the x plus 7, so I'm bringing it to the front. It doesn't technically have to be in front. And then x squared minus 1. And if you got that far, I'm impressed, but you're wrong. Does anybody want to tell me why I'm wrong? Ooh, the new guy. Nobody else knows? Oh, somebody else knows. Good. Okay, new guy. What's wrong?
You can factor x squared minus 1.
You can factor x squared minus 1 because it's a perfect square and a difference of squares. Now that I'm telling you can factor it, hopefully you can figure out how to factor it. X plus 1, x minus 1. The most common mistake on the test is going to be giving an answer that isn't factored all the way. And almost everybody fell prey to it. You didn't notice that that could be factored. So what I want you to do at the end on the test is look at your answer and go, can I factor x plus 7? No. Can I factor x plus, oh, I can factor x squared minus 1. I got to factor it then. All right. Now, if I said this whole thing was equal to 0, do you get that's going to be an x-intercept of 1, an x-intercept of negative 1, and an x-intercept of negative 7? You with me on that? All right, good. So just reminding you about the real roots. Those would be x-intercepts. Okay. Now, one last thing. I taught you this the other day, but it's been too long now. It's been a weekend, and that gives you like every reason to forget everything. Do you get that this parabola is a parabola because it's x squared? Is the right end going up or down? I know. Do you know? Up or down? It's going down because of the negative in the front. Does that ring a bell? Do you remember hearing about that the other day? Okay. It's even, so both ends are going the same way. Does that ring a bell? All right, how many terms does this polynomial have? 1, 2, 3 terms. It has 3 terms, so it's called a what nomial? Trinomial. And it's, the number at the end is kind of a big deal. What's that number at the end? That's the y-intercept. That's the stuff you forgot since Friday. All right. So, this negative in front means down on the right. So if I was going to sketch it, it's going down on the right. Since it's even, it has to be going the same on the left. And it'd have a y-intercept of negative 7. So like, maybe it's something like that. It's a parabola that's going down on both ends and goes through negative 7. Okay, there's your 2-second reminder of how to do the stuff from before the factoring day. But now you're into factoring, and tomorrow we'll be even into more complicated factoring. It actually can get more complicated, mostly just because you have to learn how to do long division. To prep you for that, would you know how to go 2 into 70? Because if you're like, oh, I'd use a calculator, you can't. And you have to know how to long divide. If by tomorrow you don't know how to long divide, then how am I going to teach you how to long divide when there's variables in it? Okay, so if you never learned this, or your teachers thought it wasn't important, they were wrong. It is important to know how to long divide for this day, tomorrow. So I'm just prepping you for this. Here's how you long divide, everybody. Would you agree 2 goes into 7? Maybe not evenly, but it goes in. How many times does it go in? 3. You may want to write this down to remind yourself the steps of long divide. 2 goes into 7 3 times. Then you multiply 3 times 2 and you get 6. Then you draw a line here. And then I'm saying it this way on purpose because of how it works tomorrow when we do polynomial long division. I'm going to make this the opposite of what it was. Before this, your teachers probably just said, now you subtract. But it's actually technically, you make this number the opposite of what it was. Now I combine the numbers, and 7 and negative 6 combined makes 1. Why don't you just say subtract? Because when we do with polynomials, you're combining like 2x and negative 3x. You aren't always subtracting. Okay, and then I bring down the 0. Do you guys remember the bring down the 0 thing? And then does 2 go into 10? How many times? 5. And then to make sure you finish this right, you do 5 times the 2, and that makes 10. And look, there's no, what's that word that starts with an R? Remainder. There's no remainder. Okay, good. That's just a reminder of how to long divide. You're going to need that tomorrow. And I wanted to get your brain remembering how long division works. Okay, now your homework is about some big old nasty factoring problems. So would you please find the homework in there? Is it a Schoology quiz or a worksheet? I forgot. Okay, I will cut it down because these are like usually too long. So give me a second, but start on number 1. I'm for sure assigning number 1. And I'll tell you which ones to do and skip. All right. The very first one was x to the 4th minus 13x squared plus 36. Did you look for a common factor in everything? Because if you thought about it, you win. Then we're going to make parentheses like this, and it's probably going to be an x squared and an x squared to make an x to the 4th. And you always do the signs next, and it's all pluses, so it must be a plus and plus. And then, do you think that a 6 and a 6 is going to make the outside and the inside make plus 3 or 13x? Sorry, I'm going to clean this up. That is a plus.
Minus 13x.
Is it a minus? Thank you. That makes a big difference. Thank you. Minus 13x squared. Then I copied it wrong. I apologize. I had a plus in there. So there has to be a minus. And it definitely is not a 6 and a 6. But it's a minus and a plus. No, wait. A minus and a plus can't make a plus 36. Must be a minus and a minus. That's how we always start, is looking at the signs. And now, that 36, could it be a 6 and a 6? No, because it'll never make a negative 13. Do you get a 9 and a 4, though? And then you might think you were done. But do you get it can be factored again? You look at your factors and you go, oh, that's the kind I can factor again. X plus 2, x minus 2, and an x plus 3, and an x minus 3. Now, in case you're like, why is there a number of x-intercepts? Well, I can look and see 1, 2, 3, 4 things make this equal to 0, so that is the number of x-intercepts I have. I have 4 x-intercepts. For the future, some of your problems are going to look like this. That has an x-intercept of 4, but try figuring out what makes that part 0. Nothing would make that part 0. At least, wait, no, actually, wait, I'm wrong. If I put plus here, then nothing can make that part 0. Which means this part has an x-intercept. This part, there's no way. You can't think of anything to put in there that would make that equal 0. Because you'd have to have something squared that came out to a negative, and that would mean imaginary numbers, right? So that's not real, which means there's be an imaginary part. If you had to get the imaginary answers, imaginaries always come in pairs of 2 because you got a plus and a minus in your quadratic formula, remember? So they'd always, if there's ever an imaginary, there's 2 imaginaries. They come in sets of 2. That would be a real root. That would be imaginary roots. And this is an x-intercept. These are imaginary. They don't have x-intercepts. All right. I'm going to have you do 1, 2, 3, and 4. And then you can skip the whole last page. Just problems 1, 2, 3, and 4. And that's all I got for you for today.